Howdy.
Hey, how's it going?
All good. How are you?
Doing all right.
Hmm.
Good morning.
Do you think do you think we'll get like a big turnout today as well? Like last week?
Yeah, I feel like it's generally about the same size.
Nice.
Yeah, people are generally pretty good about showing up to this meeting, I think.
Yeah.
Good morning, everybody.
Good morning.
Morning.
The day of Pyro. Richard, your camera did a very dramatic zoom in. That was very good. Very cool.
Yeah, it's one of those new MacBooks that is like, I don't know,
Mhm.
around. It's kind of scary.
Right. Okay. I was like, does he have some kind of camera crew or something going on? That's cool.
Yeah, no.
And on Michael's here. Man, the whole crew's rolling in. Love it.
Hello.
Hey. Hey.
Okay, well, let me share my screen. And in that moment, it's ringing at the door. I'll be back in a second.
I wonder if soon we can get these calls to 30 attendees. That'd be cool. It's amazing to see them over 20 consistently.
Yeah, it's really awesome. Come a long way.
I'm back, sorry. Okay, let's open the minutes for today. Oh, a lot of people are here. Great. Good. So, welcome to the Hiero TSC meeting today. If you are the first time here, and if I look at it, I assume I see some names I'm not aware of, so maybe some people are for the first time here. Welcome to that meeting. Like any meeting of the Hiero project, this is an open and public meeting, which means feel invited to join our meetings, including the TSC meeting. Feel yourself invited to leave comments here in the meeting, discuss with us. You find all the meetings we are doing in our public calendar, which you can find on the Hiero main page, on our GitHub main page, or in the meeting minutes. And the only thing that is important is if you attend those meetings, please be friendly to everybody in the meeting when you start discussing or contributing. All those meetings happen under the code of conduct of the Linux Foundation. So yeah, please be friendly to each other. And next to that, all those meetings happening under the antitrust policy of the Linux Foundation. And with that said, we can move to the agenda for today, which is quite short, but I know we have a lot of topics, but I was coming back from the US, was jet lagged, have not read Richard's message, and I know we have a lot of hip topics today that currently don't make it into the agenda, but I believe we can talk about that today. So on the agenda, the first point is the Hiero CLI, and I know Mikael is here and he has moved the topic forward. So I would suggest have another look at that one first, maybe do a vote for that one, and then Richard move to you with the hips. Would that make sense?
Sure.
Okay, perfect, cool. Mikael, are you okay with that too?
Yeah.
Okay, should I just stop and let you share the screen?
Yeah. Let me share it. Which one? Which one? Transferring. Yeah. Yeah. So as requested, let me put this a bit bigger. Is it good for you now? Can you see it clearly?
Yes,
Yeah.
that's good.
So as requested, I updated the proposal with a lot more details so we can set a bit more of a new standard for like future proposals. First of all, I got a couple of extra supports for the project. So AJS also supported now Dipti. She was also building on it. And Michael Bennett, he has actually been rewriting the state management feature, bringing it a bit up to date. So that's also nice. I included the history of the project, like how it started under the developer advocate team, what my initial vision was for it, and then how like the multi-step operations, like the script blocks got added. I added the information on the personas, some of the pain points that I try to solve, or that the project tries to solve. We got in total 12 releases so far now. First release was on March 2nd, so that was with the help of the DevOps team. They set up like the full CI/CD workflow, and they also published the package to NPM at the time. And now from June, I picked up coding again, like after almost 1.5 years. And the most recent version now is version 0.9. I pushed about like 6 new releases like in the last 1 month, 1.5 months. I looked at the contributors as well. We got 8 contributors in total, so it's not a lot. So yeah, Michael Bennett. So this doesn't include, or this includes Michael Bennett, who's now working on it. Some of the details of the project are 19 forks, 22 stores, and 13 watchers. And then I added a lot of details on the architecture. I think that's going to be helpful. So the way it's structured is we have a command layer where the commands just get in. We have a business layer with a lot of utilities who do like there are related actions. We have state management. This has been rewritten using ZooStand package, which is a popular state management package by Michael Bennett. We have an API layer, but this one is not very elaborate. It only supports a couple of queries like account queries and some transaction queries, but it's there, it's ready for it. The application uses TypeScript, so there's type safety, and all of the testing uses Jest, and we run the test against a Hiero local node. And then if we take a bit of a deeper look, you can see the structure of the project is the commands. Utils is like the business layer. We have the state layer, APIs. This is like an input folder for smart contracts, all the type information, and like the main anchoring file for the CLI. And then finally, some information like the vision for the project. We wanted to be like the #1 tool for the community, a tool where other developers can build on top of. So it should be like the base layer for all kinds of further interactions and tooling that we want to build. So do you think this is like sufficient details, or is there like still information missing you want to see?
No, I think this is a really great example. There's a lot of good points here. Thank you.
All right.
Yeah, agree. And I think 8 contributors is not a small number.
No, but it's only internal mostly, and I think 2 external contributions. So from that perspective, it's not a lot.
Yeah, but you already have external ones, so that's great.
Yeah.
Cool.
Yeah. So that's it.
It's quite good too. Yeah. So question to all TSC members here in the meeting. Are you good to vote on it? Or does anybody is not good to vote on it? And let me just check if we have quorum. I see 1, 2, 3, 4, 5, 6 people. Yeah, that's good. Okay. Nobody says something, so I assume we good to do a voting on that. Brandon.
Yes.
Let me go through.
One second. There was a question just asked in the
Oh,
chat.
I haven't seen that.
What are the
Sorry.
key differences to Solo? So they're fundamentally different tools in that Solo lets you establish, it's like Solo and Hedera local node have more in common and more overlap, I should say. Solo lets you deploy an entire network, and the CLI lets you work with a network. So you would use Solo to say, give me a single node network or 5-node network or whatever. And then you'd use the CLI in order to create accounts. And there are some commands in Solo that let you create an account and whatnot. But this CLI is more full-featured. It would let you do all kinds of stuff.
And I forgot to add that Michael Bennett is also working on Solo support. So the single node deploy command will be supported, and the Hedera network section will be dynamic. So you can also load any kind of network you want to define or the Solo ones.
Nice.
Sorry, carry on.
Richard.
Yes.
Michael.
I vote yes.
Milan.
Yes.
Stoyan.
Yes.
I vote yes. Sorry. I think I asked everybody, right? As far as I can see it here in this list. Which means we have 6 yes, which means it's, yeah, approved. Congratulations, Mikael,
Nice.
for that project. Cool.
What would be future steps or?
So future steps, we have a Hiero community transition bi-weekly meeting that is in the public calendar. The next one happens directly after this call. So it's like every second week after the Hiero TSC meeting. And that meeting is for, discussing project transitions and how to get the projects to Hiero.
Okay. Should I join it today or next week?
Roger is here, Jessica is here. What do you think? Do you have any specific topics for today, or would it make sense to already discuss that today?
I don't think so. We had anything planned for this week, so I'm open for the discussion. But I would like to Roger to confirm.
I have no preference, no strong feelings one way or the other. I'm very ambivalent here.
Okay, then it's up to you. You can join this week already.
Yeah, let's do it this week. I'll be out next week and the week after, so I'll join later. But I'm on a team offsite, so I'll drop now and I'll come back the next hour if that's fine. Sorry about that.
Absolutely.
All right. Thank you, guys.
Okay,
See you
bye.
in a bit.
Good. So yeah, as said, the agenda is not that much filled in the minutes document this time. But I know we have several topics. One topic I would like to bring forward is that we now have the official pull request for the graduation of the Hiero project. I'm fine to share that here in the chat if people want to have a look at it. And as you can see, the first comment on it is already quite positive, and if everything works well, it will be on the list for the tech meeting already this week. So I hope to get some answers about the graduation state of Hiero in the near future. Good. That's all I have. Richard, what about?
Yeah, I can share my screen.
Yeah, sure. Give me a second.
So there's a few things that I want to share. The first one is last night I created a new hip tracker. It's in the in the Hiero Ledger projects. So it's on GitHub and public, so anybody should be able to see it. I was starting to lose track of which hips we had brought to the TSC and which we hadn't. I would go to all the minutes and try to say, but sometimes like today we're going to be talking about hips that aren't on the agenda, and sometimes I couldn't find them in the minutes, and I was like, or I was looking in the wrong place, or I went to watch the videos and the transcripts trying to remember what did I show and what did I not show yet. So I thought, okay, what I'm going to do is create a hip tracker that can keep track of all of our hips and where they are in the status. Let me also do a Hiero improvement proposals. Just bring this up real quick to kind of show what I was working from. So hip 1 defines the hip process, and it has this diagram in here. And the diagram shows, that's a simplified one, here's the full diagram. It shows sort of the flow of how hips go through the process. And I just ignored the Hedera part because that's Hedera's business and not Hiero's. So what I did is I said, okay, we've got all these different steps: draft, deferred, withdrawn, review, rejected, last call, Hiero review, approved, final, and replaced. All these blue boxes here. And I wanted to represent them in the hip tracker so that we could keep track of where the hips are in this workflow. So, okay, I don't know why these things always go. I just have to like refresh the page. Oh,
Yeah.
Good job, GitHub.
GitHub is super buggy. I was not able to get to the TSC repository before the meeting. I don't know what's up there. I think they have a problem.
Yeah, Richard, I got the exact same message when I tried to load your board there.
Yeah, well, the CEO left yesterday, and who knows what's going on. So I don't know if you guys saw that, but the CEO for GitHub left, and now it's getting slurped into Microsoft, and I'm sure that has nothing to do with it. Okay, so here it's back up. So, so I have the board, and I have all the different statuses, and I have a description for each one of the different statuses, what they are. And I just tried to stick with exactly the names are in that flow chart so that it all lines up. And when I went through it, I was like, oh, there's some improvements I think we could make to some of the names and flowcharts and stuff. But just as a quick primer on this subject. So when you first start writing a HIP, it's in draft phase. And this basically means that you've started development of the HIP, you're open to conversation, things like that, but really it's still with the author who is working this thing out. And I know for myself, I do most of my drafting before it's ever uploaded so that I make sure that I have something that's sort of like semi-decent form. And also you come up with all kinds of ideas during the draft phase that you just sort of discard and change. And so I work on, it's much like I would do on code. If I had a branch and I was working on some code, I would, do a bunch of development locally. And once I feel like I'm pretty good with it, then I push it up in onto a branch. That's sort of your draft phase. It's like you're working on it, but it's not really ready for people to review yet. Once you you can decide at any time to withdraw your HIP. You got it up there and you go, oh, never mind, it was a bad idea. You can withdraw it. That's fine. But then you go, once you've gotten to the point where you're pretty comfortable with it, you go down to the review phase. And review just means I'm ready for everybody to start reviewing this thing. And typically, if you're doing a draft, you should have your PR in draft mode. And when you're ready for review, you switch it to review mode. When it enters review mode, if it's one of this is a time for the author of the HIP to bring it to the TSC. So we should be watching these, when something goes into review mode, that's when it's like, oh, that should be presented to the TSC. And that then gives all of everybody who attends the TSC or watches a recording insight into the HIP and opportunity to ask questions live and so forth. Once we've had that review at the TSC, we can change the state to last call. And it starts a 2-week timer. I said 1 week because currently we've been doing 1 week, but HIP 1 says it should be 2 weeks. I think that we should generally do 2 weeks. It basically gives us enough time from the time that we present it to the time that we vote on it. And it gives the rest of the community, anybody who's been watching the recordings or joined us in these meetings, opportunity to participate in the review over that last 2-week period. Then after it's been in last call for 2 weeks, we will bring it to the TSC meeting for a vote. And then when we vote on it, so anyway, after it's done as 2 weeks, we switch it to the higher review. That means it's time for us to come vote. Once it shows up here, then we'll vote on it, and it's either approved or rejected. So on the one hand, there's a lot of states here, and like the state management, it's like, oh gosh, I got to change the state on everything. But on the other hand, it actually is all these different steps. And with the state management, it allows us to keep track of where things are. So that being said, we have 3 that are in review. This one we're not prepared to present today because I only discovered it last night. So this is another example of why I want a HIP tracker. I didn't even know Lazar's Hashgraph. I didn't even know that we had a HIP update that we were working on until I was starting to go through all the open PRs. And I don't have all the open ones here. These are just the ones that I was able to identify, briefly yesterday. Mostly I was just looking for the ones that I was working on. So this one, even though it's in review status, because it really should be reviewed, we haven't looked at it, but I'm not ready to present this one today because I'm not up to date on exactly what this HIP is doing. It's sort of related to another change that I do know a lot about, but I don't think I didn't see anything written up about it. So we need to prepare this and bring it. The other 2 that we have in review status, I'm prepared to present today, and then that can start our timers so that we can get a vote on these. And then hello, this guy in last call. So like this is a prime example. I was like, I swear I've presented the fee collection account, but I didn't see it in the meeting notes that I had gone through. And I asked on the TSC, like, hey, have you guys seen, and several of you were like, I'm pretty sure that was presented. I'm like, I think this one's in last call and we can actually vote on this one today. So if but I don't remember. I mean, do you guys remember this one? Have we presented this one? Is it really in last call or is it in review? I want to get the status right.
I recall you presenting it and kind of sharing the ideas of, the single fee collection account and kind of the
Yeah.
24-hour subsequent transfers and stuff. So I recall you presenting it to the group, but that may have not been reflected in the meeting summary. Maybe it just wasn't called out by the hit number.
Yeah. Okay, so I think this one's in last call, then we can vote on that one. So I have these three prepared for today. And then there's others that I don't even know if this one's actually in draft stage or not. I'm not sure. And then I had a couple on here that we actually had already done. I was trying to add in the ones that we had done as well. And you can see that I put a date in here so we can keep track of which day we reviewed it and which day we voted on it. And I'm not sure which day this was, but it's been a couple weeks for sure. I don't think this was last week. At least, I don't know. Time flies. It's hard to keep track in my head. So let's go to each one of these, and maybe we can start with the last call, which is the simple fees. No, it's not. It's the fee collection account, and then we can do these other two here. So as a refresher, the fee collection account HIP, the proposal is that we create a new account, 802. 802 will be governed by the network. Nobody, including the admins of the network. So for example, the Hedera Council do not have control over this account. It's controlled by the code, just like account 800 and 801. This particular account will be the fee collection account. So what will change is we will start paying all fees into 802. And then once per staking period, which is, on the Hedera network is configured to be daily, what it will do is transfer into account 98, 800, 801, and all the node operators into each of the node accounts. However, what portion of those fees belongs in each one of those accounts. And the reason for doing this is really it's primarily, I would say, performance and scalability. And then the second reason would be just sort of clarity for users, in that when you go look on Hashscan now, of course, you see, things going into all these different accounts. And that's a little bit, it's just noise. It's just noise that users don't really care that much about in terms of where each one of these different, where this is all going. But it's also, when we are handling a transaction, for every transaction we handle, every one of those transactions, we have to load and deal with basically 5-6 accounts. So if I'm doing a basic crypto transfer, I have my source account and my destination account. Then I've got account 98 and I've got account 800 and I've got account 801. At a minimum, I have to deal with those 5 accounts. And instead, we'll turn it into, I have my source account, my destination account. I still have to deal with account 801 account 800 if the source or destination account is getting a staking reward. Otherwise, I don't have to deal with 800 at all. And then I just have to deal with 802. So it gets us from 5 accounts down to 3 or 4. And that also means fewer accounts get updated each transaction. And every time that we update an account in a transaction, a record of that goes into the block stream. And account 98, for example, has a massive number of keys on it. So it's just like we're just pasting that into the block stream over and over again. So by using account 802, which has no keys on it, it's going to be very small. It's basically just the account balance, and protobuf encoded, it'll just be a few bytes. So we reduce the amount of stuff that we have in the block stream. We reduce the number of accounts we have to touch, and we make it simpler for users in that they can see that, where their fees are. They can see how much of the thing was fees. Instead of having it broken out into a whole pile of different accounts they have to add together, they just say, I paid that much in fees. Great. Also, by the way, that was helpful for some of the exchanges. Like Coinbase was interested in making it very simple when they go and try to figure out what was a fee, because they have to keep track of fees for tax purposes, things like that. So they're kind of happy with that idea as well. So anyway, that's the background to this HIP. If there are no, so first off, any additional questions, comments, or concerns?
There is one question in the chat about the keys of that account.
Yeah, so why does it have no keys? So the nice thing about it not having keys is that it's kind of the whole premise of the code is law sort of concept. And also, in the case of Hedera, they don't want keys to these accounts because there are legal things that you have to consider about, who owns it. And in this case, the fee collection account, it's not owned by anybody. It's owned by the network. And the network is responsible for distributing those fees. So that's it's literally not owned by any particular entity, and that's the reason it doesn't have keys. Yes, distribution is automated. Exactly. No problem. All right. Hendrik, if you'd like to run I propose that we vote on the fee collection account.
Yep. I'm fine with that. Let me look here again at the list. Yeah, Richard, you're the first one here in my list.
Yeah, sure. I approve.
Brandon, Milan,
Yeah, I vote yes. Great idea. A lot less overhead, I imagine.
Michael,
I vote yes. I think this is a great hit.
Stoyan,
Me too. I vote yes.
and I vote yes too. That's 6 times yes.
Oh, for goodness sakes. Okay. I'll update the display.
Yeah, that's so horrible.
Okay, we'll move on. Okay, the next one is add stale status code. So this one I'm just presenting today, and we will vote on it. I would like to do it in 2 weeks. I may ask for expedited vote next week, and the only reason I say that is we're working really hard on getting the 065 release done and ready for production and to go to testnet in a couple weeks. And this may be something that we need in 65 for our performance testing so that we can run the performance tests. So I may ask for an expedited thing next week, but I would prefer not to. I prefer to just follow the 2-week process and sort of get into that rhythm. This one had some good feedback yesterday. So, but let me just sort of explain the idea. So,
Richard,
yeah.
there's another question regarding the last tip in the chat. It's if headers create a new fee account, how will it add to the fee collection account? Maybe you can answer that first before we.
Yeah, I don't understand the question. So the way that it works is that every transaction we pay into the fee collection account. And then once per staking period, which on Hedera is configured to be once per day. The Hiero network can configure it to be shorter or longer periods. But once per staking period, at the very beginning of that period, we distribute everything out of there to where it should go. So if there were some new account that was created, we would update the logic to the dispersal so that it comes out of the fee collection account, as opposed to getting added to the fee collection account. So we have a body of logic that's responsible for determining what the fees are and sticking them into the fee collection account. And then there's logic that decides how to get the stuff out of the fee collection account. Oh, I assume that you're asking that because it doesn't have keys. But yeah, it's code change. We'd have to make a code change. There'd be a HIP. We'd have to approve it. That would change the, how things are dispersed or how things are collected. All right, cool. Okay, so stale status code. I should have prepared a diagram for this one, but I'll give it, let me go here. Consensus node. There's a document that's sort of buried, needs to be unburied, but this is actually an important document. Okay. So this document here, consensus layer markdown document, this is our official documentation for the design of the consensus layer of a consensus node. Consensus nodes are split into two parts. There's the consensus part, and then there's the execution part. Consensus is responsible for gossip and running the hash graph. And then the execution part is responsible for taking the transactions in consensus order and executing them, creating a block stream and exporting it, all those pieces. And this document covers the design of the consensus layer, and it's our official document. So if there are changes made to this document, those are the, and these are not like HIP level. Some of these things are represented in HIPs, but this is specifically like sort of the implementation design, you know, how the thing is designed to work. And in here, there's a whole section on foundational concepts, events, transactions, finality, liveness under stress, what happens when we're under CPU pressure, execution is slow, all this kind of stuff. And in this document, we break out all the different modules, the core modules that make up the consensus layer. Not all of these are implemented yet in code. This is just the design of, you know, what we're building. So for example, the sheriff component doesn't actually exist yet, but it's getting built. Whereas these other four components already exist today and are operating. Now, if we go look down in let's go find it, stale. There's a definition in here of what a stale event is and how the stale events work. So I'm just going to describe it. I'm not going to read it to you, but just so I want to make sure everybody was aware of this document. This is a really good thing to read and understand if you're interested in sort of the guts of sort of, you know, the foundational pieces of how consensus layer is built. When you create, if you are a node, you receive transactions from the outside world. Okay, here we go. And when you receive transactions from the outside world, you bundle those transactions inside a thing called an event, and you gossip the event to all the other nodes in the network. And gossip, of course, could be like complete broadcast where you send it to every single node, which is what we do today. But there's a point where your network gets so large that it makes more sense for you to have several hops. That's all sort of the implementation detail and gossip. The key thing is that you take some set of transactions, you put it in an event, and you gossip that event to everybody. And when you receive events from other people, and events have parents, you know, there's a self parent and another parent, and this is what forms the hash graph. So when we see the hash graph A2, you know, all these A events are created by Alice, and all these are created by Bob, the B events by Bob, and so forth. And when I create a new event, let's say I'm creating A2 event, I'm Alice, I'm going to have one parent is going to be one of my own events, and another parent is going to be somebody else's event. So they're always building on each other's events. That's how you get gossip about gossip, and the whole hash graph algorithm works on this principle. But it's important to keep in mind that we're not gossiping transactions individually. We're bundling them inside of events and gossiping events. Okay. Now what happens if I have an event and it has a whole pile of transactions in it and I gossip it to the world and nobody builds on my event? And by that I mean nobody has an event that uses me as the other parent. Well, let's take a look at B1 right here. See B1? Nobody's using him as another parent. B2 has it as a self parent, but nobody has it as another parent, right? Not C2, not D2, not A2, none of they've all dodged, or D1. Nobody built on D1 except for D2 itself. So at this moment in time, from the perspective of these events, B1 and D1, nobody else in the network has seen it. So those transactions cannot come to consensus. But we build another layer of, you know, there's another round of gossip. We create more events. They have other self-parents. And now you can see that C3 can see D1 now. Okay, so D1 is seen by D2 and it's seen by C3, but it's still not seen by anybody else at this point in time. So not enough people have seen D1. But if we go up another layer, what has happened? Well, B4 sees D3, sees D2, sees D1. Okay, now I have 2/3 of the network who's seen it. B4 has seen it, C3 seen it, D2 seen it, greater than 2/3. So that means that D1 is now good and those transactions could be involved. But what happens if we went many rounds and not enough people see this event? They just haven't chosen it by virtue of whatever events they built their events on top of. We just never got to the point where this guy was seen. If that happens, then the transactions inside the event itself becomes stale. And because we don't want to have sort of an infinite number of old events that we hold on to, just hoping somebody eventually builds on it, we have a limit, and it's configurable on the network. I think we have it at 26, which is called the ancient round. So basically, if you've gone 26 rounds and you have an event that hasn't had sufficient visibility from the rest of the network, then the transactions inside of it become stale. On mainnet, I'm not sure if this has ever happened. In performance testing environments, it happens. We're generating events at such a rapid pace that sometimes it happens. And we have metric to keep track of that, but it creates some problems for the performance test client. And also, since it is theoretically possible to happen, it's important to make sure that developers have a way of dealing with stale events. Today, you don't have any visibility into this at all. As an application developer, you submit a transaction to the network, you go ask for its receipt. When you get that receipt back, it either says unknown, which means it's really a horrible name for the thing, but anyway, it's a very old name. We can't change it now. But unknown doesn't really mean it's unknown. It means the status is unknown. We actually have basically, if you query a node and it gives you back a transaction receipt that says unknown, that means yes, I have this transaction. No, I don't yet know what its state is. Did it succeed? Did it fail? And the reason I don't know that is because it hasn't come to consensus yet. So instead of unknown, we should have said awaiting consensus or something. That would have been a better name for it. But anyway, that's what unknown is. So and then once it has come to consensus, then we know what its disposition is. Did it succeed? Did it fail? If it failed, which of 500 error codes was it? There's information about that. But we don't ever talk about stale. Stale events never come to consensus. So they stay in the unknown state, which is awaiting for consensus. They stay there until they eventually time out. And all events have some, all transactions have a timeout maximum configured on the Hedera network at 3 minutes. It can be configured different for different Hiero networks, but there's some time limit. And when that time limit expires, then the client is supposed to resubmit the transaction if it wants to. The problem is we may know that this thing is stale within 10 seconds or 20 seconds or 26, 30 seconds in our case on Hedera. In 30 seconds, we're going to know if that event is stale or not. And instead of making you wait 3 minutes to resubmit, we could do it in less time than that if you knew what it was. So with all that background, the whole point of this HIP is actually relatively straightforward, relatively. We just want to add a stale status event or status code to response code enum so that you as an SDK user or a happy user, you can see that your event is stale and resubmit it if you want, or not if you don't. Whatever you want to do. That really was the point. There is some complication in it. You'll find a conversation that I started with Derek last night. He had a great comment here. This is why I'm not pushing for this too quickly. I think he made a good point, and we need to think a little bit more about it. There's a few other comments, but not a huge number. I think this is the only sort of interesting, complicated one. The idea is that if you have a transaction and its state is unknown, we can transition it to stale when you know that it's stale. Then when you resubmit the transaction, we have to reset it to unknown. And there's some corner cases where in the duplicate transaction case, things could get a little bit interesting. So that's a place for those who are doing reviews to dig in to what's going on in this conversation. But that is stale events. Any questions before we move on to simple fees that you'd like to discuss here, or you can all just participate in the review? All right. Okay. Moving on to simple fees. Okay. Simple fees is a HIP that has very little, I'd say, external impact, but is fairly complex in terms of the code changes that will be involved. Our existing fee system is a very complex system, and this is going to make it a lot less complex. But because we have to take something that's fairly complex and reduce it, there's a lot of work that we're going to have to do as a consequence of this HIP. But the reason that we're interested in this HIP is really, number one, reducing the complexity, both in terms of how we calculate it and how we configure it. I think I might be able to pull up on the fly the existing config files, but I have to go dig a little bit for them. But they are complicated. If you were to look into this thing, maybe this will help motivate this HIP in terms of why we're doing this. Let's go to configuration. I don't know if we have it overridden anywhere. It might be down in the yeah, I don't remember where that config file lives. I have to go find it. I don't know if we have it built into the resources here. Yes, we do. No, we don't. That is the helpful one. That one actually looks decent. It is, yeah, I don't have the file available. But what we did was the original design has a whole series of different fee components. This is bytes per transaction. I don't even remember what VPT is. Verifications per transaction. I think that's what that one is. This is RAM byte hours. This is storage byte hours, gas, bytes per record. And I'm not sure what SBPR is, to be honest with you. It might be storage bytes per record. So there's like all these different components, because what we were trying to do is we were trying to set up a pricing scheme that was based on resource utilization. But it turns out that isn't often the way that fees are computed. Often fees are computed based on market dynamics. Sometimes we price things below the, when I say we, that's my Hedera hat on, because every Hiero network can set up its own fee schedule. In Hedera, sometimes the prices are chosen because of sustainability of the network. Like, this is a price that we need in order to be able to continue development. And then there's other prices that are set based on market competition. It's like, okay, this is actually a little bit of a loss leader, but it's, equal with what's going on in the market. There's all kinds of reasons why you might choose that. There's another reason is that sort of, well, anyway, those are the main ones. I was going to say market demands, but that one's actually covered by the storage byte hours. So, there are other reasons why you might set a price. And when we go to CoinCom and we say, okay, what do you want to set the price of this transaction to be? And they choose a price for the transaction. We would then have to take that price of the transaction and go back and try to reverse engineer each one of these different components to be some number that when we ran the calculation would actually produce the number CoinCon told us to produce. So maybe if we actually put the number, and the other thing is, these numbers change all the time. We go make a change to, let's say, the virtual map storage system, and all of a sudden the storage byte hours might change. And then we'd have to go and recompute the values for every single transaction so that storage byte hours still produces the same prices that CoinCom wanted us to use. It's just a really laborious, impossible system to try to keep in balance. The consequence of that has been that sometimes what we have on, you guys know fees.hedera, oh yeah, whatever. What is it? I thought it was, it's hedera.com/fees. Sorry. I just always think it should be the other way around. Whenever you come in here and do the fee estimator, sometimes you'll find that the fees aren't exactly the same that you see in Hashscan. You say, why is that? The reason for that is because all this fudging that happens in order to try to get these numbers to line up so that we produce the right thing in the end. So he said, all right, this is silly. Wouldn't it be much better if we could simply define what the fees should be in US dollars, and then we will compute everything correctly. And so basically take a basic fee schedule and stick it in here. Sophie says, I'm confused by some of the phrasing. A transaction will have a base plus extras. Yeah. So let me explain. So again, this is a fairly detailed HIP, so it would take some time to read through it. We went through many revisions. I think this has been on our thinking about and revising for maybe a year or so. And we went through lots of different concepts. But basically what we ended up with is we wanted to have fees be as understandable as ordering. Initially, it was buying a car, and then we came up with an even simpler model, which was ordering a pizza. If you go to a pizza store and you say, hey, I would like to buy a pepperoni pizza, they say that'll be $10.99. Okay, in the old days. Now it'd be like $24.49 or whatever. And then you say, oh, and I would like extra cheese and olives, and then they add those extras on and they give you your new price. And we want fees to be the same way. There are so we're going to say that there's a base fee and then there's a bunch of extras. Now, a fee is actually made up of several components. There's the node component, the network component, and the service component. A user doesn't need to know anything about node, network, and service. That is an implementation detail, but it's an important one that we needed to specify because any implementation of a Hiero node that was going to be compatible with other ones has to deal with fees in the same way. So from a user's perspective, all you know is that there is a base and there are extras. And it's actually a little bit more complicated than that, Sophie. It's not just base equals service, network, and node. I can get down to some of the other examples. I would say to start with, from a user perspective, you can ignore node, network, and service. And if you are interested in node, network, and service, then consider base plus extras is the total amount that's available. And then some of that goes to node, some of that goes to network, some of that goes to service. So it's more like, when you're computing all the fees and then you're computing how you distribute those fees. So node, network, and service is how it's distributed, and the total amount is base plus extras. Okay. Yeah, I don't know, Sophie. Maybe she asked, is there a section that explains that more clearly? I don't know. Maybe the HIP isn't as clear, and you can just leave a comment on here and I'll rewrite the intro or the rationale. Or if you have some suggestions, I'll fix it up to make it more clear. I suffer from I have too much context. So for me, when I read it, I'm like, yep, that's exactly right. And then but I have too much context that I'm working with. So I appreciate that. Yeah, I'd like to make it more clear. Okay, so as far as the user stories, as an app developer, I want clear and concise breakdown of all the fees so I can understand what changes I make in my code, what impact that has on fees. As a Hiero developer, I want to test and verify the fee logic in my implementation. So when those of us who are building Hiero, we want to be able to have really great tests that tell us exactly that we are producing exactly what we should be. And as an HBAR holder who staked to a node, I want to confirm that my share of staking rewards is being correctly calculated and distributed. As an auditor, and by the way, there are auditors who go and look through to make sure that all of our fees are correct. I want to independently verify that fees charged by the network align with the published fee schedule. So we really want to make sure that everything that we are publishing is exactly what we're charging. And as a network governing authority, such as the Hedera Council, I want to be able to validate as well that everything is being charged correctly. So they need to trust our code, and we want to make it very simple and straightforward so that they should be able to go to Hashscan, they should be able to click on any transaction, and they should be able to say, oh yeah, okay, that's all good. You guys are charging the right amount. And then there's some user stories for node operators as well who want to make sure that their portion of collected fees is correctly deposited in their account and so forth. So, okay, so when we get to the specification, fees obviously are an essential part of the system, protects the network and incentivizes correct behavior. And every transaction's fee has these different components. There's a node component, network component, service component. Sometimes we just call it like the node fee. Sometimes we call it the node fee component, but it's the same thing. It's just like if you took the whole body of fees that you've charged, they get broken down. Some of it goes to the node, and this node fee is if you're a node and you brought in the transaction from the outside world, you verified that transaction, you submitted it to consensus, you get paid a fee. There's a reward for you for doing that. If you then once it gets gossiped to the network, it goes to all the nodes in the network, there's a network fee. And the purpose of the network fee is to make sure that the network, all the nodes in the network are properly compensated for the work that they did, the cost of gossip and consensus, signature verifications, managing the fee payment, and there's blockchain stores. They have to produce stuff that goes into the block stream. So the network fee is to cover all of those costs. And then the service fee covers all the remaining costs of the execution, which is actually handling the transaction. So if we thought about it from, let's say, account creation, if you're going to do a crypto create, the node that you submitted your crypto create to is going to get a little fee. A fee is going to get paid to that node. Or a portion of your fee will get paid to that node. And all the nodes in the network that gossiped your crypto create and came to consensus, verified that your payer signature was valid and all the other keys that you had, those signature verifications worked, and they do the fee payment and to pay for the crypto create and to store a record in the block stream that says this crypto create happened. All of that goes into this network fee, and that ends up getting distributed equally to all the nodes of the network. And then the service fee is that every single node now has to store some additional state on their hard disk, and you need to pay for that. So the service fee component covers that, which is also paid to all the different nodes in the network. And there's some diagram here. Where are you? Oh, anyway, so this diagram shows, which is obviously way too small in this view, but you can go in here and take a look at it. It kind of shows in fact, let me see, can I make you bigger? Let's view this thing real quick. Okay, it shows sort of like different stages that your transaction is in during the whole flow. If you submit a transaction and it fails to ingest at all, you don't pay anything. If it succeeded in being ingest, then it's going to go to consensus, and maybe it passes, maybe it fails consensus. In that case, you're still going to pay the node and network fee. Well, let's say failed consensus, that's not possible, so forget about that. But if it's a duplicate transaction, you're going to pay node and network. If it's a throttled transaction on the back end throttle, which we talked about last time, you'll pay node and network. If it's part of an atomic batch transaction that hasn't been handled, you pay node and network. If it gets to being handled, but it's semantically wrong, like it was just, well, you're going to pay node, network, and service. If it's inconsistent with state, and all these are described in the HIP, what these things mean, you'll pay this. If it's out of gas, you'll pay this. If it's an internal error, you'll pay this. If your transaction was submitted by a bad node, then these are what ends up getting paid, but not to the user. These cases in bad node are charged to the node. So these cases up here are charged to a user. These cases down here are charged to a node. And the details on all this is in the HIP. So especially as we're running low on time, and we'll go into super detail on that. But in the, so let me just walk down at user story specification. We have those three things. And then I go through each one of them. What is an unreadable transaction and how is it charged? What is an invalid transaction? How is it charged? What is an unhandled transaction? How is it charged? And not just how, but why. Why do we do it this way? If it's a bad transaction, how is it charged? If we have congestion and there's, one of the back end throttles is kicking in, oh, sorry, this one's different. This is congestion pricing. There is a specific congestion pricing that exists today. So if a throttle reaches a critical sustained level, we have a congestion pricing today on the network that would kick in. And there's a basic scaling factor that is applied. So whatever the fee is, we then multiply that for congestion. And then I go into how we configure this thing. And I wanted to just spend a few minutes on this part, and then I think we'll be done. So in terms of how you configure it, there will be a JSON file. And we're going to have a section called extras, and then node, network, service, and then unreadable. Now, in the extras section, there will be a list of extras. And these are all the things that you'll get charged, for each signature in the transaction, for each byte in the transaction, for each key in the transaction. And here's a table that lists every single one of the extras that we're going to define. So how many airdrops, or how many allowances, or how much gas, or how many custom fee, if there's a custom fee defined for an entity on creation, then the custom fee extra is being counted. Created accounts, like how many hollow accounts were created, that kind of stuff. So these are all the extras. Okay. And every extra is defined. Let me go back up. Every extra is just a name and a fee. And all the fees are in tiny cents, which is there's 100 million tiny cents per cent. So there's it's 10 to the 10 in terms of dollars, 10 to the 8 in terms of cents. So we just define it as in tiny cents. At first I was like, that is just like a ridiculously small number, but it turns out for gas you need it. So it's like, okay, we'll just do tiny cents then. And we have plenty of precision to be able to do that. Then okay, so now we have a list of all of our different extras. Now, when we get to node, we have what we do is we specify, okay, how are we going to compute the node fee component? And we're going to say, well, I can assign some base price to the node fee component, and then I can define the set of extras. And when I say which extra is going to be used, you'll notice I don't repeat what the price of the extra is, because you just define the extra once and then you just use it everywhere. But what you can do is say how much of that extra is included automatically. So I can say, okay, the base price is going to be whatever this is, 100,000 tiny cents. But if you send any bytes more than a kilobyte, if for each additional byte over a kilobyte, we'll charge you the bytes extra, which was defined up here somewhere, this much per byte. And for each transaction you send, you get one signature for free. Every additional signature, you'll have to pay the signature extra. And this is how we will compute the node fee component. Don't do that. Oh, I should stop selecting things. Anyway, that's how we're going to compute what the node price is. And in the network component, all I do is specify a multiplier that says, okay, whatever the node component was that you computed, just multiply it by this multiplier, and that'll be the network component. And there's some specific reasons why we did it this way. Specifically, the important thing is both node and network should be based on bytes and signatures. That's the essential thing. All the other things about whether it was a crypto create or this and that, we do not want to include that in the definition for node and network fees. I really want the incentives for node operators to be correct. I want the node operators to have no incentive to prioritize one transaction over another. I want the node operators to simply say, thank you for your transaction. Let me put it into the event and gossip it to everybody else. And for that reason, we just do bytes and signatures. And I don't care, every node operator has a limited amount of space that they can use for an event. Events are not open-ended in terms of their size, because that would be an attack vector. So there's a specific size limit to an event. And we want to make sure that whether you put in lots of little transactions or one big transaction, you get rewarded exactly the same. And so that's really the intention of doing it based on bytes. We have to include signatures, so there is a slight, that I lie slightly in that if I have lots of little transactions, there's, well, actually, there's more work I have to do for signatures. And since one of them is given away per transaction, it doesn't do me any good to prioritize that. So it's really sort of egalitarian. Every transaction comes in. My goal as a node operator is to stick, or as a node, is to put this in an event as quickly as I can. And the network is kind of the same. At the network level, what are we doing? We're doing gossip, we're doing fee calculation, we're doing all these things. None of them have anything to do with the type of transaction. It's totally agnostic. It's exactly the same for every transaction. And it's going to be, you know, so we just can just specify a multiplier, and it's impossible to configure it wrong in terms of adding the wrong sort of extras or anything. So that's why we did it that way. Then we have a section for every service, and inside every service we have transactions and queries. Some queries you pay for, some are free, and then you have all your transactions. And when I come in and I define a service and I define its transaction, again, it's just base and extras. It looks exactly like it did up here for the node component. All I'm doing is I'm saying, okay, what's the base service fee for this transaction? And what are the extras that go into computing the service fee component for this transaction? And it works exactly the same. In this case, it's like, oh, if you're doing a crypto create, you get 1 key for free in your new account. If you wanted to have 10 keys in your account, then you're going to pay for 9 of them over and above the base price. So you take the base price, plus you take the price for 9, add it together. That gives you your service component. And I had some like example language to sort of explain how those fees are put together. And then for queries, you define your query, and your query can have there's an extra goodie down here, which is that you can say this query is free. So it's like, I don't have a base, I don't have extras, it's just free. And you can have other queries where it's like, yeah, actually the base is 0, but here's the extra and you have to pay for every byte. You can configure it however you want. And the goal of this HIP was not to say what those prices are, because you can have completely different prices for different Hiero networks. So, and also it's not the goal to say, you know, exactly all the details, because you might set up a Hiero network that has its own custom services, right? You could, since our stuff is modular, you could create a new module with a new service and go add it in and then configure it itself. The goal of the configuration section of this HIP is to just say, this is how configuration works, and it works in a modular way. If you create a new sort of service module and you include it, you're just going to create a new service section with all of your queries and transactions, configure it however you like, and off you go. Then there's a section that talks about how to parse it, and then there's the actual schema down here. And as I was presenting, I think I saw an inconsistency between one of my examples and the schema. The schema is correct. The example is incorrect. I'll go do another pass and see if I can correct that. And then what we have down here is we have a list of all of these different services that exist in Hiero today, all of the API components that make up Hiero today, and what every single one of those extras are that's supported by each one of those. So if you look this in Markdown mode, you'll be able to see this much better, this table down here. So you'll be able to see, you know, okay, crypto create has signatures and keys, but it doesn't have some of this other stuff, and so forth. And then we also define a mirror node section. And the mirror node section, so the important point here is that there's going to be a new API on mirror node that will let you estimate a fee. So all you do as a user is you create a transaction, and it can either be in JSON format or in binary protobuf. You submit it to that endpoint, and you'll get back a breakdown of your fee estimation. There is a complication in that, since fees are partially determined by the intrinsic structure of your transaction, but some transactions are, or maybe all in some ways, are also impacted by the current state. So for example, if you go to let's say you're doing a crypto transfer, right? If the source account well, let's assume the source account exists. The destination account may or may not exist yet. If it doesn't exist, there's an implicit crypto create, and that's going to charge you more money. If it does exist, then you don't have to do the crypto create, and it'll just, you know, do the transfer. So if you're doing a fee estimation, it sort of depends on the current state of the system. If you say, I want to do this crypto transfer, how much is it going to cost me? It's like, well, do you want me to take into account the state or not? So what we do is we added to the query a query parameter, and that query parameter is called mode, and you can either specify intrinsic properties of the transaction only or include state in doing the estimate, and it defaults to state. So by default, what would happen is you go to this thing, you give it a transaction, the mirror node will look at the existing state of the system and it'll say, oh, yes, well, because that account doesn't exist yet, it's probably going to cost you this much, and give you back an answer. And in the response that you get back, it will tell you also what, so here's the response. It'll tell you what mode this estimate was done in. You know, was it done with state or just the intrinsic properties of the transaction? So there's a little bit of there. And again, it's just an estimate. So things like if you were using the SDK and you were using this system in order to try to get a more precise estimate for what your fee should be, you probably do the same thing that is done on other networks, and you'll take the fee estimate and add 10 or 20% and just say, okay, I'm going to fall within this zone fairly safely. Because you know the system is asynchronous. There could be changes to state between when you did the estimate and when you actually submit the transaction, but you know, I think most of the time it's just going to work fine without any problem if it's checking on state. So that was, like I said, it's from a user's perspective, there's like no impact. You just create transactions, you submit transactions, you get charged transactions, and the fees and everything are going to be almost identical to what they are today. Like you're not going to see anything from all of this. But what this will do is it will allow us to, well, first of all, from a performance perspective, there's a lot less calculation that has to go in to compute your fees. The fee computation is much more straightforward. We're just basically, it's essentially we have a table in memory that just says, okay, what are all the extras and what is their price? And then in the handling logic, we just say, okay, give me the this transaction has these components and this kind of stuff is in state. Pass it all to the fee engine. Fee engine computes, gives us back a fee. We split it and it tells us node, network, and service components. We charge the right stuff and we're done. Whereas today there's a lot more bespoke logic. All of that will be handled inside that fee engine. That exact same fee engine implementation will get reused by the mirror node. So that means that it'll be very accurate. Also, that exact same fee engine implementation will be used by this guy, which is not the case today. You know, this thing's fee estimator beta because the implementation of it is different than the implementation we actually use on mainnet. But that won't be the case anymore because we'll have the exact same fee engine calculator that we use here, that we use on the mainnet code, that we use in the mirror node. We'll be able to reuse the same thing everywhere, get it all accurate. That's long story just to say that the let me see, where were we? Back over this guy. Long story just to get to the point that users won't see a difference. Developers will have fee estimation capability, which is a nice addition that they don't have to have programmatic fee estimation capability, and the implementation is going to be way cleaner. So that's what the HIP is for. Thank you for staying late. Appreciate it. And I don't know if you guys have any questions, but I think best to dig into this one soon because there's a lot of detail here to just review and see if you're comfortable with it. If you have any, you know, find any bugs or flaws and or things that are concerning, and then we can get started on, you know, well, we can vote on this one in a couple of weeks and you know, hopefully get it done before the end of the year. That's the goal. All right.
Thank you.
Thank you.
Okay, we already like 10 minutes over time. So as you know, other topics for today, but thanks for doing that extra 10 minutes to get the presentation by Richard. And see you then all in one or another Hiero meeting.
All right. Thank you.
Bye.
Thanks, everybody.
Thank you. Bye-bye.